All right, here's an example of Unit 5, NTI Unit 5, Target 2, number 12. Of course, yours could be a little different and may make it a little more challenging, but the same premise exists. You got two squares being multiplied. So the 3 is on the outside, will stay on the outside, but then you're multiplying the two radicands, x to the 5th, y to the 5th, times the other radicand, 5, x to the 9th, y to the 8th. So under that radical, you're now going to have a 5, and x to the 5 times x to the 9, you're going to have 14x's being multiplied. So it'll be 3 times the square root of 5x to the 14. The y's, there's y to the 5th times y to the 8th. So there's going to be 13 y's underneath the radical. Now that means there are perfect squares under the square root that need to be reduced. So normally don't show this much work, but I'm going to go ahead and show it so you can see it on this one. That would break apart into the following. So it's a lot of work, but let me explain what it is. The 5 is still 5. X to the 14th is x squared times x squared times x squared. There's 7 of these x squareds for 14x's. With 13 y's, you can make y squared, y squared, y squared. You can make 6 y squareds, but you'll still have one other y right here for the 13th y. And then I will be a little lazy and just reduce these as they sit instead of making them their own individual square roots. I'm going to reduce the x squareds that are perfect squares. The square root of x squared becomes x again and again and again and again until you have reduced 7 x's there. So those are no longer under the square root because each one of them were their own square roots and they're reduced to x. Same thing with the y's. There are 6 of them. So all 6 of them will reduce. They were their own square roots, square root of y squared, square root of y squared, etc., 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 and they all reduce to y. However, there's still this 5 and still this y that are not going to reduce. So put it all together and you've got this. You've got the original 3 out here times all these x's and all these y's. 3 times all those x's times all those y's times the square root of 5 and the square root of y. So nothing else is going to reduce, so you put it all together under everything that's outside of the square root together and everything inside the square root together, and it would look like 3x to the 7th, y to the 6th, and the square root combined would be 5 times y under the square root. So final answer, without any absolute values or anything, because we're not talking about those this year, would be 3x to the 7th, y to the 6th, square root of 5y. Hope that helps.